Okay, guys, here we go. Day 5, arithmetic series and geometric series. So all a series is when you take a sequence and you add up the numbers in between. So you can see here's our sequence, and now we're just going to put a plus sign between the numbers. Addition sign appears between the numbers in the sequence, and yeah, let's check it out. So what if I asked you to find the sum for this here? Well, it definitely would be a pain in the butt because I would have to put in the number 4, right? And we would get 7 plus, then I would have to put in the number 5 and get 8 plus the number 6, right? And so on. And I would have to keep doing that all the way up to 28, which is like crazy. So we have a formula that we can use instead. So here's the formula. So it's a formula for finite arithmetic series. So it's also called the nth partial sum formula. The nth partial sum, because whatever, if you're doing first 5 terms, first 100 terms. So the formula works like this. Say you're going to add up 7 terms, then you would put in 7 for n, here and here. And then a sub 1 is your first term, and then a sub n is your last term. It's your last term because whatever your n value is going to go in here. And then you divide the whole thing by 2. So it's a very easy formula. It's nothing confusing. It's not on the reference sheet, so this one you do have to memorize. But this one is like, I don't even think this one has ever been on a Regents, but I'm just showing it to you anyway, just in case. All right, so Sarah wants to save for a special dress. Oh, we should, you know what, let's go back and use the formula on that question. This one here. Let's use it on this one. Okay. All right, so how many terms do we have? All right, so this is a little tricky too that we need to talk about. So if we're starting with the number 4, and we're ending with 28, the way you figure out how many terms you have is you always subtract 28 minus 4, but then you always add 1 back on. And that'll tell you how many terms you have. So you start at the top, subtract the bottom, and then you add 1 on, and that'll always give you how many terms you have. So we have 23 terms. So let's use our formula. So S of 23 equals 23. First term, we'll plug in 4. Last term, we'll plug in 28. So 28 plus 3 is 31. And then we'll divide by 2. Okay, I just have to do that calculation. And we get 437. Okay, so it's a shortcut, a quick way to get the sum. All right, let's go back to doing a word problem here. All right, Sarah wants to save for a special dress for the prom. The first month she saved $85, and the next 9 months she increased the amount she saved by 8. Okay, so I think we can tell that that's our common difference right here. And we can tell that this is our a sub 1. So they want to know what is the amount she saved over the 10 months. So look, you could write out a sub 1 is 85, and then you could add 8 onto that and add 8 onto that. And then add up all those numbers. You could, but I'm trying to show you, something different that you could do here. So when I start to write out the formula, S sub 10 equals the first, let's write the formula first until we get good at it. Oops. Okay, eraser's not working. Okay, lovely. Let's write the formula. Okay, so we're going to do 10 months. First term is 85. And we'll notice that we don't have the last term. So in order to find the last term, remember our explicit formula? A sub n equals a sub 1 plus n minus 1 times d. We could use that to find the last term. So the last term is going to be a sub 10 equals the first term plus 10 minus 1 times your common difference of 8. So our last term is 157. So we'll go over and plug 157 in. And we get $210. Okay, so some of you guys might have wanted to just write out the numbers and add them up. You can. Okay, here's the part that's more important. This one is on every single Regents. The sum formula for if it's a geometric series. This one is on the reference sheet, so if you guys turn to the back of your packet, you will see that it is there. Yeah, this markup tool stinks because now it's only staying in black. Okay. All right, so find the sum of the first 8 terms of the sequence. So instead of trying to figure out what all those 8 terms are and then adding them, we can use this formula. So here we go. So S of 8 equals the first term minus, now let's use some parentheses here, the first term again times the common ratio, which I'm going to find, raised to the 8th, 1 minus, and again we have to find that common ratio, so let's go over to the side and find it. Remember, the common ratio is second divided by first. So the common ratio is -3. Throw that into your calculator, and we get 8,200. Remember, you guys can pause the videos and do stuff. Okay, moving on. A little Regents question application using this formula. Okay, Alexa earns $33,000 in her first year of teaching. So that's going to be my A sub 1. And earns a 4% increase. Okay, so right away, again, we know that this is 0.04, and it's going to be 1 plus 0.04. Otherwise, if we multiply by 0.04, it would not be an increase. Remember, it's just with our exponentials what that little bubble would be. So this is our common ratio. All right, write a geometric series formula S sub n. Okay, so that's this one. And it's on the reference sheet, so we're just going to replace in. Now, I wish my highlighter tool was working here. I don't know why this always goes crazy on me. Right, still not working now. So when we write when we write a formula, a model, an equation, remember you always have to have 2 variables, an x and a y. So here's my y, that's going to remain. My first term minus my first term times my common ratio. And here's like my x value, right? When you write a model, an equation, you have to have an x and a y. And then 1 minus 1.04. Now, it doesn't say in simplest form, so you could just leave it like this. I wouldn't bother doing anything else. What could you not do? You could never subtract these two 33,000s ever. Okay, the only thing you could do with cleaning this up would be the bottom, but you can just leave it. Okay, now it says to use the formula, so second part. Use the formula to find her total earnings, right? And this formula gives us totals. It's a sum formula, adds everything up for 15 years of teaching. So 15 is going to be my n value. So we're just going to replace in 15 into that formula. So S of 15 equals okay, throw that into your calculator. And there we go. Okay, there's her total earnings. So that's a pretty popular question. That one we should know how to do. Okay, let's try another Regents question. All right, a little tougher this one, but stay with me. So Yasmin decides to put $100 into a savings account each month. The account pays 3% annual interest compounded monthly. Okay, so we got to take care of this first. And this is my ace of one. But let's go take care of this. All right, so definitely I'm going to change that to be 0.03. But remember the formula for when we compounded monthly or quarterly? Remember what the bubble was? The bubble was 1 plus r over n. Right, so that part we have to take care of. So it's 1 plus 0.03 over 12. So 1.0025 is my common ratio. So that's a little tough, but we should go back to the exponential unit, and remember that. Okay, how much money will she have after 1 year? Okay, well, it's tough because 1 year, but this is the amount she puts in each month, so we have to make sure that we use 12 for our n value. Okay, so let's see. So here's what I noticed. I noticed that 2 and 4, those look like the formula that I just taught you. So let's do the formula I just taught you and see if it works. And then 1 and 3 look like, they don't look like the sum formula. They look like a formula just to find, like the explicit formula for geometric. All right, so let's use the one I just taught you. Let's write it again. Remember, it is on the reference sheet. Okay, so we're going to do this for 12 months, 1 year, but remember, we have to be in the same units. All right, so now we can clearly see that it is choice 2. But look what they did with choice 4. With choice 4, they took into consideration that you might not remember that compounded monthly, that we need to use this part of the formula. Okay, so please be careful. Okay, we're getting there. We're going to do 3 more. That's it. Oh, no, we're not even going to do 3 more. We're going to do 2 more. That's it. Okay, Kristen wants to increase her running endurance. According to experts, a gradual increase of 10% per week. So there it is again. If you want to come over right away, 0.10, 1 plus 0.10. So if my common ratio is 1.10. Can reduce the risk of injury if she runs 8 miles in week 1. So we know that that's ace of 1. Which expression can help her find the total number of miles? So total number, right? That's adding everything up. So we can use the formula that I taught you today, or you can look at yesterday's summation. Yesterday's summation also adds everything up. Here's today's formulas. So it could be any of these answers. So why don't we start out doing, why don't we start out doing today's formulas and see if we find an answer. Okay, so let's write it again. Let's get good at memorizing it, even though it is on the reference sheet, but it is good to recognize it. Okay, so we're doing this for 6 weeks. So S sub 6 equals first term minus the first term, the common ratio raised to the 6th, all over, I need to move this up again, 1 minus the common ratio. Okay, so here's the thing. If I do this bottom part, if I do 1 minus 1.10, do you get this value right here? Right, we don't. We're going to get a negative 0.1. So now neither one of these can be the answer. Sorry that I can't change color. This is so crazy. I don't know why not. Keep staying black. Ay, ay, ay. Okay, so now it means that one of those sigma notation ones are it. So let me see. If I look at both of them, do you remember what the explicit formula is for geometric from day 2? Right, that's our explicit formula for geometric. So if we plug into that, our first term times our common ratio raised to the n minus 1, we can see that it's choice 2. So it's just a matter of realizing that the sum could be done 2 ways. We can use the summation from yesterday's lesson, or we can use the nth partial sum formula from today's lesson. All right, we're just going to do one more. We'll skip 6 because I don't want to make things too crazy for you guys. And that's a rough one. So let's just finish on 7. Okay, we don't need to do 8. All right, we'll finish right here. So it says, given the recursive definition. So now let's go back to day 3. We can see recursive. They're giving me the first term is 3, so a little review question. And let's read this together. The next term is the one before it times 2. That's all that means. So what kind of formula is this? This is times, so it's geometric, and they want me to write the explicit formula. So we just did that a second ago. A sub n equals a sub 1 times r to the n minus 1. And let's just replace in. So a sub n equals the first term. The common ratio, right, is what we're multiplying by. So times 2 to the n minus 1. So just a little review from the other day. Okay, now it says find the sum of the first 8 terms. Now they're telling me that I have to use the geometric series formula. I have to. So that's S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. Remember, it's on the reference sheet, this formula. Okay, so here we go. 8 terms. S sub 8 equals the first term, ratio raised to the 8 over 1 minus 2, and we get 765. Alrighty, so this is a super duper important lesson. They love to do questions with this formula here. Love it. And then you're just looking for a total, a sum, when it's a geometric sequence. Okay, so homework for this one is just delta. So it's delta U12, day 5. All right, guys, remember, you can always go back, pause it. You can rewatch the videos, but, do the best you can to learn this stuff. All right, bye.